dear students, today we are going to discuss about one of the most important topic, refrigeration and air conditioning. So refrigeration and air conditioning. These are the most important topic in our day-to-day life. This is the most important topic in the mechanical engineering subject. So first of all, refrigeration. Refrigeration may be defined as extracting heat from a body. So there are various types of refrigeration processes are there. Very simple thing, main definition. Refrigeration may be defined as the removing heat from a substance under controlled condition. Then extracting heat from a controlled condition. Basically, refrigeration may be defined as the branch of science which deals with transfer of heat energy, extracting of heat energy from a medium which is already below atmospheric temperature. Generally, the refrigeration works below atmospheric temperature. So refrigeration, as per the definition, refrigeration may be defined as the branch of science which deals with transfer of heat energy, or extracting of heat energy, or removing of heat energy from a body or from a substance which is already below atmospheric temperature. So refrigeration. So there are various terms of refrigeration. The substance which is extract heat from a body is known as a refrigerant. Refrigerant are the substance which can extract heat from a body. There are various types of refrigerants are there, as we know. In the simplest form, ammonia, carbon dioxide, sulfur dioxide, chlorofluorocarbon, R11. There are various types of refrigerants are there. R11, R12, then CCl4, ammonia, NH3, NH4, carbon dioxide, sulfur dioxide. In a simple form, our NaCl solution. This is a simplest form of that is the refrigerant. The substance which is used to extract heat from a body are known as the refrigerant. Similarly, the device name is known as the refrigerant. The device name is known as the refrigeration, and the process is known as the refrigeration process. Similarly, the cycle on which it works is known as the refrigeration cycle. So there are three terms are there. Refrigerant are the substances which is used to extract heat from a body. Similarly, refrigeration is the process known as the refrigeration. The process, cooling process is known as the refrigeration process. Similarly, refrigeration cycle, the cycle or process is known as the refrigeration cycle. So before we go into the refrigeration, we have to know why we study refrigeration. There are various topics in our mechanical engineering subjects such as thermodynamics are there, pumps are there, then machine dynamics are there, machine designs are there. Then why we study refrigeration? Why? That is the applications of thermodynamics. Why we study that is refrigeration. Basically, we study refrigeration because in our day-to-day life, everywhere we may find the applications of refrigeration. So where there is a heating process is there, we have to need the refrigeration. Basically, the treatment of air conditioning, that is treatment of air. When we feel the hot condition, we have to require that is cooling. When we feel that is the cooling, we have to require that is the hot portion. So basically, we study refrigeration because the application, the laws and principles and applications of refrigeration are found everywhere in our day-to-day life. Okay. So everywhere, so there are various devices in which power producing devices are there, power consuming devices are there, and various industrial applications. Everywhere we have found the applications of refrigeration from everywhere in our day-to-day life. Suppose this classroom, this is AC classroom. We have to, that is the applications of refrigeration. So already basic definition we already taught that refrigeration. Suppose a classroom, we have to maintain a classroom at -2 degrees centigrade. Suppose another example, we have to, the fish is taken from the Andhra Pradesh to Odisha. So throughout this way or passage, we have to maintain the temperature of -2 degrees, so certain temperature. So refrigeration is a process of heat removing a body or heat extracting a body, or basically at a controlled condition. We have to maintain that temperature at the desired temperature. So various applications of refrigeration, there are so many applications of applications of refrigerations are there. Applications of refrigeration everywhere in our day-to-day life, there are a scope of applications or applications of refrigeration. Everywhere in our day-to-day life we may found the applications of refrigeration. First of all, refrigeration are used for the manufacture of ice and similar products. Manufacture of ice and similar products. Okay. Everywhere we are fond of ice creams are there, various manufacturing of ice and similar products. Basically, second one, the refrigeration are used for the preservation of food items, various drinks and medicines. We have found that various medicines, they are written that store in a -2 degrees centigrade, 2 degrees centigrade, 3 degrees centigrade. Basically, refrigerations are used for the preservation of food items and drinks or medicines. Another one, I have already told that the refrigeration, where there is a heating process, we have to need, that is the refrigeration. In a various rocket and air propulsion, then jet engines, marine ships. Everywhere there is a applications of refrigeration. Or various power plants are there. In a power plant, everywhere or in our day-to-day life, there is a applications of refrigeration. Various industrial applications are there. Industrial applications, everywhere there is, we found the applications of refrigeration. So there are various processes of refrigeration. So there are various processes are in a refrigeration. Vapor compression cycle, vapor absorption cycle, so various refrigeration processes. Though there are various types of refrigeration process, what the following are important from the subject point of view. First stage, this is the ancient type of refrigeration process. Air refrigeration cycle or process. Air refrigeration cycle or process. Vapor compression refrigeration cycle. Then third one, vapor absorption refrigeration cycle. Then another one is gas refrigeration cycle. And another one is thermoelectric refrigeration cycle. So there are various types of refrigeration cycle. These types are important according to the subject point of view. Air refrigeration cycle, vapor compression refrigeration cycle, vapor absorption cycle, then gas refrigeration cycle, thermoelectric refrigeration cycle. Before we go into the various thermodynamic cycles, we have to know what is the unit of refrigeration. One of the most important term is unit of refrigeration. In which unit we have to measure the refrigeration. Basically, the unit of refrigeration is known as TR. That is ton of refrigeration. So what is ton of refrigeration? So very simple. Ton of refrigeration, when we are going to buy a refrigerator or air conditioner, there is written that 1 ton or 1.5 ton or 2 ton. These are the unit refrigeration of unit. So the basic definition of refrigeration is it may be defined as the refrigerating effect produced by uniform melting of 1 ton of ice from and at 0 degree centigrade during 24 hours. Very simple thing. The unit of refrigeration, it may be defined as the refrigerating effect produced by uniform melting of 1 ton of ice. Well, this is a 1 ton of ice. 1 ton is equals to 1000 kg. 1 ton of ice, 1000 kg. So refrigerating effect produced by uniform melting of 1 ton of ice from and at 0 degree centigrade during 24 hours. So what is the mathematically? Mathematically 1 ton of refrigeration is equals to, I told the 1000 kg, 1 ton into 335. The latent heat of evaporation of ice is 335 kilojoule per kg. 1000 divided by 335 divided by 24 into 60, which is equals to 235 kilojoule per minute, or which is approximately is equals to 210 kilojoule per minute. Why it is taken as 210 kilojoule per minute? Because first of all, 1 TR is derived from the US. In American, 1 US ton is equals to 2000 pound and 1 pound is equals to 907.5 kg. So when it is written 907.5 kg, it is approximately it is equals to 210 kilojoule per minute divided by जब 60 हो जाएगा, that is 3.5 kilojoule per second. Kilojoule per second is equals to what? So 3.5 into kilowatt. So 1 ton of refrigeration is equals to 3.5 kilojoule per second. So फिर से 1 refrigeration unit, it is the amount of refrigerating effect produced by uniform melting of 1 ton of ice from and at 0 degree centigrade during 24 hours. This is ton of refrigeration. So there are various processes of refrigeration processes there. So first of all, air refrigeration cycle, vapor compression refrigeration cycle, vapor absorption refrigeration cycle, then gas refrigeration cycle, thermoelectric refrigeration cycle. So first of all, so what is air refrigeration cycle? Okay. So air refrigeration cycle, basically the cycle in which air is used as a working substance is known as the air refrigeration cycle. In olden days, air is used as a working substances. Its heat carrying capacity is very low. Its thermal efficiency COP is very low. So it is used in a ancient days. So in a air refrigeration cycle, there are various cycles of air vapor compression. So reversed Carnot cycle. One of the best example is reversed Carnot cycle is there. Then Bell-Coleman cycle is there. Bell-Coleman cycle is there. Bell-Coleman cycle is there. Reverse Joule cycle is there. Breton cycle or reverse Joule cycle is there. Reverse Breton cycle. Breton cycle is there. Breton cycle is there. These are the examples of air refrigeration cycle. Before we go into the air refrigeration cycle, we have to know what is the main difference between a refrigerator and heat engine and heat pump. So in a figure, this is a first of all, this is a heat engine. For a heat engine, so there are 3 parts is there. One part is this is known as a source part, and another part is this is reservoir. This is known as the sink. There are 2 reservoirs are there. So first of all, this is Q2 amount of heat is supplied from a high temperature source. Basically, this is high temperature. This is known as the T2. Then Q2 amount of heat is supplied from a high temperature source, then partially converted into work done. Then the remaining heat is rejected to a low temperature sink Q1. This is another reservoir which is at low temperature, that is T1. So this is a figure of a heat engine. Basically, what is a heat engine? The heat engine is a device which converts the heat energy into mechanical work done. So for a heat engine, high temperature source is there, Q2 amount of heat is supplied from a high temperature source, then partially converted into mechanical work done, then the remaining heat is rejected to a low temperature sink Q1. So for this figure, suppose this is work done, then how much work done is there? Work done is equals to, from the above side, Q2 amount of heat supplied minus Q1 amount of heat rejected, that is Q2 minus Q1. Then for efficiency, What is efficiency? Efficiency may be defined as the output by input. That is, efficiency is equals to output divided by input. That is what we desire divided by what we pay for, or basically work done divided by heat supply. Very simple thing. Work done is equals to Q2 minus Q1 divided by heat supplied is equals to Q2, or from the process theorem we may write down T2 minus T1 divided by T2. This is all about the heat engine. What our case is known as the refrigerator. In a refrigerator, this is the reversed heat engine. This is the reversed heat engine that is working in the opposite direction. Here this is a source is there, this is refrigerator is there, another part this is sink is there. So here this is Q1, this is Q2, and work done on it. This is most important is there. In a heat engine, we may obtain the work done. For a refrigerator, this is a refrigerator. In a refrigerator, we have to apply some work. We have to working for a refrigerator, it needs some work. So this is known as the reverse heat engine. Why it is known as the reverse heat engine? That is working in the opposite direction. Here the arrow marks are in downward, but here the arrow marks are upward. This part is important for a refrigerator. So Q1, this is T2. Amount of heat extracted from a lower body. So according to, we have known that according to second law of thermodynamics, we cannot extract heat from a lower body without aid of an external organ. So here Q1 amount of heat is rejected from a lower body temperature, work done on it, then Q2 amount of heat is supplied to a high temperature source. So similarly, here there is a efficiency for a refrigerator. We have to find out that is COP, coefficient of performance of a refrigerator is equals to amount of heat extracted from a lower body, amount of heat extracted from lower body divided by work done. So here this one Q1 plus W is equals to Q2. Work done plus Q1 is equals to Q2, or implies that work done is equals to Q2 minus Q1. So as per our definition, COP is equals to amount of heat extracted from a lower body divided by work done. So amount of heat extracted here Q1 divided by W, or equals to Q1 divided by Q2 minus Q1, or equals to T1 by T2 minus T1. This is the COP of a refrigerator. Similarly, another device is there. This is known as also another device known as the heat pump. This is also known as the reverse heat engine. That is also working in the opposite direction. This is source part. This is Q2. This is Q2. This is Q1. This is that is sink T1. In a refrigerator, this part is important. What for a heat pump? Heat pump is basically used to heat a medium. In a winter season, we require heat pumps, that is to heat a medium. This part is important. How much heat is delivered to a hotted body? Okay. So same case for a heat pump, we have to find out the COP of a heat pump. COP of a pump is equals to Q2 amount of heat delivered to the hotted body, Q2 by W, or equals to Q2 by Q2 minus Q1, or equals to T2 by T2 minus T1, or COP of a pump equals to 1 plus COP of refrigerator. COP of pump is equals to 1 plus COP of refrigerator. Okay, these are all about the basic parts of the comparison between heat pump, refrigerator, and heat engine. Okay.